All right, I want to begin here in this section with section 3.3, video, part 1. This video will probably have anywhere from 3 to 5 videos, but want to continue talking about the stuff about polynomials. So let me start out and give you two definitions right here, and then I'll tell you to copy this down. So let me give you these two definitions first. Write down this first definition. The degree of a polynomial function is the largest power on the variable. Okay? So, write this polynomial function down here. F of x equal, or y equal, same thing. Y equal x squared minus 2x minus 15. Write that down, right there. So, if I was to ask you right here, what degree is this polynomial function? The degree is 2. Now, what's the significance in the degree? What's the big deal about the degree? Take down this next note. The degree of a polynomial function determines the number of zeros it has. Now, let's talk about what we learned last time on what does it mean to be a zero. Remember, you have found one of the zeros. What does that mean graphically when you find a zero? You're finding where the graph crosses the x-axis. So the word zero and the word x-intercept is the same thing. So a zero is just a number. So if I say 7 is a zero, that means the graph crosses the x-axis at 7. If I say -4 is a zero, that means the graph crosses the x-axis at -4. How do we determine if a number is a zero? Remember what we said do is you do synthetic division with that number, and if you get a remainder of 0, then that number you found is one of your zeros. So if I do synthetic division with 8, and I get a remainder of 0 on that polynomial, that means that 8 is one of the zeros to that polynomial function. Which means if you graph that polynomial function, it will cross the x-axis at 8. Now, it will cross it at other places if it has other real zeros. All right, so write this problem right here down. And then I want to ask 3 questions. And this is just kind of a review of what we did last time. When you look at this polynomial function, it's a second degree. So that means it has 2 zeros. All right, now, whenever it has 2 zeros, those zeros can be anything. They don't have to be whole numbers. They can be fractions, decimals, they can be all kind of crazy stuff. So this polynomial has 2 zeros to it. Now, I want to ask the question, is 1 a zero? Is 5 a zero? And is -3 a zero? Well, how did we do this last time? What you do, if you want to know if 1 is a zero, you take 1 and do synthetic division on your polynomial function. If you get a remainder of 0, then the answer is yes. If you do not, then the answer is no. All right, so I'm going to slide this up right here. Pause the video and copy this page. Okay, I'm assuming you've already done that, so let's talk about it now. So, how do I determine if 1 is a zero? You do synthetic division with 1 on this polynomial. 1, -2, -15. There's no skipped powers. Bring down the 1. 1 times 1 is 1. -2 plus 1 is -1. 1 times -1 is -1. -15 minus 1 is -16. So is 1 a zero? No, because the remainder is not 0. Okay, what's the next one I'm testing? 5. So is 5 a 0? Put 5 here. Bring the 1 down. 5 times 1 is 5. Negative 2 plus 5 is 3. 5 times 3 is 15. Negative 15 plus 15 is 0. So yes, 5 is a 0. It's one of the two zeros. Now, let's try to see if negative 3 is a 0. Well, when we do negative 3, bring down the 1. Negative 3 times 1 is negative 3. Negative 2 minus 3 is negative 5. Negative 3 times negative 5 is 15. Negative 15 plus 15 is 0. So, 5 and negative 3 are the two zeros to this polynomial function. Now, you say, Mr. Rainer, how did you know to put the 5 in the negative 3? I'm not ready to discuss that yet. The main thing I want you to see is, why are these two numbers the zeros? Because we did synthetic division and we got a 0 remainder. I also want you to know that this is a second degree polynomial, which means it has two zeros, and we just found the two zeros, 5 and negative 3. All right. So, here's what this means graphically. You don't have to draw this graph if you don't want to. If I was to graph this problem right here, which we are not ready to do, I just want to drive this point home. Here's what the graph of this looks like. It is a quadratic function. It's a U-shape. Look at where it crosses the x-axis. At 5 and at negative 3. What were the two zeros we just found? 5 and negative 3. This is what else I want you to see now. If you look at this quadratic function, x squared minus 2x minus 15, this is a quadratic right here. I want to try to factor this. Did we talk about factoring earlier in the course? Yes. Look for a GCF. See if it's the easy case or the hard case, the Brew method, difference of two perfect squares. So let's see if we can factor this polynomial into two things that multiply together to give you this. All right, so if I factor this, x squared, this is a trinomial. There's no GCF. This is the easy case because of the 1. X squared breaks up x and x. Signs are different. Largest is negative, so it's x plus, x minus. I need two numbers. When you multiply them, you get 15, but when you subtract them, you get 2. This one does factor, 5 and 3, but the 5 has to be with the negative. So when I factor this factors is x minus 5 times x plus 3. These are what we call the linear factors. Now, why are they called factors? Because I just factored it to get this. That's why they're called the factors. Now, why are they called linear factors? Remember, the word linear means x is to the first power. So look at this right here. What power is x to? 1. What power is this right here to? X is 1. So this is a linear factor and this is a linear factor. This is what I'm wanting you to see. What degree is this? Second degree. How many linear factors did it have? 2. How many zeros did it have? 2. How many times did it cross the x-axis? 2. Now this is the main thing I'm wanting you to see. Is there a connection between the linear factors and the zeros? And the answer to that is yes. Here is why. X minus 5 is a linear factor. If you set x minus 5 in your head, take x minus 5 equals 0 and solve that for x. What do you get x to be? 5. If you take x plus 3 in your head and set it equal to 0 and you solve it for x, what do you get x to be? Negative 3. This is what I'm wanting you to see. The zeros for a polynomial and the linear factors of a polynomial go hand in hand. If you know one, you automatically know the other. For instance, look right here again. If x minus 5 is a linear factor, 5 is a 0. If x plus 3 is a linear factor, negative 3 is a 0. All right, so all right, I just wrote this down. I just said this, but let's say it again. So if x minus 5 is a linear factor, 5 is a 0. If x plus 3 is a linear factor, negative 3 is a 0. So help me complete this one. Now notice the linear factor has to have the x with it. The zeros are just numbers. So tell me, put what would go right here and what number would go right here and what number would go right here. So if x plus 7 is a linear factor, what would automatically be a 0? Hopefully you put negative 7. If x minus 6 is a linear factor, 6 is a 0. Now let me show you again where that comes from. And I know you can do this in your head. All you're doing is taking x minus 6, setting it equal to 0, and when you do, you get 6. That's where that comes from. Okay, now, see if you can do this one. You said, now, wait a minute, these are not linear factors because they got numbers in front of the x's. Yes, they are linear factors because x is still to the first power. So, what do we have to do to get the 0 to this linear factor? You set the linear factor equal to 0. So here's what you'd have to do. Add 3 to both sides, then divide by 2. So in this case, make sure you can see it, yeah. In this case, your 0 is a fraction. So 3/2 is 1 1/2. So what that would mean is your graph would cross halfway between 1 and 2. All right, now, can you do this one in your head? 5x plus 7 equals 0. Subtract the 7 across, that'd be negative 7. But then you have to divide by 5 to get negative 7 over 2. Now, let's see if you can go backwards with it. So, if 2 is a 0, do you automatically know what the linear factor would be that goes with it? Yes. X minus 2. If negative 1 is a 0, do you automatically know the factor that goes with it? Yes. X plus 1. If 10 is a 0, the factor that would go with it would be x minus 10. If negative 8 is a 0, x plus 8 would be the linear factor. I made a mistake right here. Back up. This should be negative 7 over 5. Right there, negative 7 over 5. So, this is what I'm wanting you to see. If you know one of the factors, you automatically know one of the zeros. If you know one of the zeros, you automatically know one of the factors. Here's a reason that's important. In the last video, did you learn how to find the zeros? Yes, you did. The way you learn how to find the zeros is if it wanted to know if a number was a 0, we would do synthetic division on it. And if you got a remainder of 0, then it was a 0. Now, here's how that's going to be tied into what we're about to do. If you know one of the zeros, then you also automatically know one of the what? Factors. So let's suppose I ask this question right here. Let's suppose I ask this question. Is x plus 9 a factor? If I ask, is x plus 9 a factor? That is the same question as what? Is negative 9 a 0? This question right here and that question right there is the exact same question. Now, why is that important to know? Do we know how to determine if negative 9 is a 0? Yes. How do we know to do that? Do synthetic division, and if you get a remainder of 0, then negative 9 is a 0. Well, if negative 9 is a 0, then what would that mean would be a factor, x plus 9. You understand the relationship there? Okay? So, let's do a couple of examples. Okay, so write this question right here down. All right, so here's the question. Is x plus 2 a factor of this right here? All right, let me ask you this question first. What degree polynomial is this? This is a third degree polynomial. So what does that mean? How many zeros will it have? It will have 3 zeros. If it has 3 zeros, then how many linear factors will it have? It will have 3 linear factors. So you say, well, Mr. Randall, why don't we just do this? Why don't we factor this like we did the x squared minus 2x minus 15? Why don't we just do our parentheses and factor this? We don't know how to factor this. See, this is a third degree polynomial. The Brew method and the easy case trinomial, the factoring that we've done together has only been on second degree polynomials. Now, if this was a second degree polynomial, I would factor it and see if that's one of them. But the problem is I can't factor this right here. I don't know how to factor that. Not only that, how many factors, linear factors, are there going to be? There's going to be 3 of them. But I don't know what they are. I don't know how to factor this. Then you say, well, then, Mr. Randall, if we can't factor this, we don't know how to answer this question. Yes, we do. Here is why. X minus 2 is a factor if what is a 0. x minus 2 is a factor if what is a 0. Now, let me flip back to the previous page. If x minus 5 is a linear factor, what's one of the zeros? 5. If x plus 3 is a linear factor, what is one of the zeros? Negative 3. So, let's answer this question. X minus 2 is one of the factors of this if what number is a 0? Positive 2. You said, well, how do we work that? We learned how to work that in the last video. If you want to know if 2 is a 0 for this polynomial, you do synthetic division on this polynomial with 2. Bring down the 2. 2 times 2 is 4. Negative 9 plus 4 is negative 5. 2 times negative 5 is negative 10. 13 minus 10 is 3. 2 times 3 is 6. Negative 6 plus 6 is 0. So, what does this tell me? 2 is a 0 because you got a remainder of 0. Now, what else does that mean then? If 2 is a 0, what would be one of the linear factors? X minus 2. Remember we did this up here a while ago? If 2 is a 0, x minus 2 is one of the linear factors. So x minus 2 is one of the linear factors. So if I want to factor f of x, let me write the original problem back down. How many linear factors does this have? It has 3 of them. We just found one of the linear factors. It's x minus 2. Now, still don't know what the other 2 are. We're going to talk about that later. But yes, x minus 2 is a linear factor. And remember, that was the original question. Is x minus 2 a factor of that polynomial right there? And what we're just talking about is called the factor theorem. When you see if it's a factor, that's called the factor theorem. Okay, we'll pause here and pick up with the next video.